This is Note-Taking Guide 8.7, Proving Similarities. So what we're going to do today is we're going to kind of look at some sets of triangles, and we're going to decide whether or not we can prove they're similar. So we're going to look at these two triangles here. Here's the beginning part of this. It says given NO over QO is equal to PO over MO. So we know that N to O, so here, over QO is proportional to PO over MO. So that proportionality tells me that I have a relationship between those two sides. So when we're proving that, now that we have that information, we can come over here and we can write that down over here. And it's kind of, I'm writing bigger than the lines are, but PO is congruent to MO. And the reason for that was that that information was given to us. So now that we have that marked, you guys, this is pretty simple to prove that those triangles are similar, because we can prove it by either angle, angle, side, angle, side, or side, side, side. So the only thing that I need now to prove that these are similar to each other is to prove that these two angles right here are congruent to each other. And I actually know that those two angles are congruent to each other because those two angles are vertical angles. So I'm going to list that angle POQ, and I'm going to say that it's congruent to angle MON. And the reason I can say that is because of vertical angles. And then the last thing that I need to do is tell that those two triangles are similar to each other, which is what I'm trying to prove. So I know that triangle MNO is similar to triangle PQO. And I know that they're similar. The reason, I should have not written that clear across, but the reason that those are similar to each other is because we proved it by a side, an angle, and a side. So side, angle, side. So doing a proof is not really that difficult to do. What we're really trying to do is prove either angle, angle, side, angle, side, or side, side, side. Those three rules that we learned yesterday. So we can use all of the rules that we know from other lessons in geometry. And we can use, like we used vertical angles here, we could use alternate interior angles, alternate exterior angles. We can use any kind of rule that we've already learned. And when we write it over here on the reasons, just write in your own words why that happens. You don't have to be super specific about it or exact. If you think that that's because of a special reason, just write that reason. And there's more than one way to do every proof. So let's take a look at the second proof, and let's just talk through this for a minute. The first thing I want to make note of is that these two are marked parallel. So I have parallel lines here cut by a transversal, and I also have parallel lines here cut by a transversal. So when I'm looking at these two triangles, I know I'm probably going to use those parallel lines in order to help me. So in the given information, and really what I'm trying to prove is, let's look down here at what I am trying to prove. I'm trying to prove that ACE, so that big triangle, is equal to the little triangle. So the big triangle's in pink, the little triangle, I just outlined it in orange. We want to prove that those are similar to each other. So in order to prove that those are similar to each other, I need to prove either angle, angle, side, angle, side, or side, side, side. So I'm just going to look to see if I can find information on these two triangles that will prove those rules. So let's just take a look at this for just a minute and look at the given. The given says AE is parallel to BD. So I already kind of showed you that we have parallel lines marked with a transversal there. So down here on this proof, they give you that information. That reason would be it was given information. So we're just going to write that they gave us that information there and then kind of complete this proof. So the next reason that they gave us is that we have corresponding angles. So I want you to take a look at these parallel lines right here. with this transversal cutting through it. And look at this upper right-hand corner of the cross that was made right here. And then find the upper right-hand corner of the cross that was made right here. Those upper right-hand corners are corresponding angles, so we could write those as congruent to each other. We also could have gone off of these two parallel lines with this transversal and done this corresponding angle with this corresponding angle. It would work either direction on that. So let's just kind of, I'm going to erase all my drawing here so that I can get some of this stuff out of the way, and we can write a congruent statement here with our angles. So I want to mark this angle congruent to this angle because of parallel lines cut by a transversal, and those are corresponding angles. So this would be angle CBD. So I'm going to go CBD is congruent to angle CAE, so from CA to E. And they're congruent to each other because of corresponding angles. So angle CBD is congruent to angle CAE. Now I know that those are congruent, so if I can prove another set of angles congruent, then I can prove angle. And I already said over here where we have the parallel lines cut by a transversal that this angle would be congruent to this angle because they are corresponding angles. So I'm going to write those over here. So I'm going to have angle CDB is congruent to angle CEA. And the reason that they're congruent, again, is the same reason as before, corresponding angles. Now I totally could have used another rule, and if anybody saw that, you might have made mention of it. But you see up here how this angle is the same in the little triangle as it is in the big triangle. So I could have just said that angle BAD is in both triangles. That would have been a rule that I would have used over here. But now that I've proven that I have two angles equal to each other, that would be the angle rule. And I can say now that the triangles are congruent to each other, which is what I was trying to prove. So triangle ACE is similar to triangle BCD. And the reason that that worked was because of angle. Just keep in mind as you're doing this assignment today that there's more than one way to do every proof. And I would just really recommend that you're really careful looking for those parallel lines cut by a transversal, because that's how you're going to get all of your information is from looking at that.